So we've finally gotten through all that power stuff. Now what happens with that power, that energy that comes out? Well, that's the job of the antenna. An antenna can sound like a very confusing thing, but when it comes down to it, an antenna is quite simple in what it does. Some analogies that you'll hear, good analogies, are imagine a perfectly round balloon or a perfectly shaped ball of dough. Imagine that as the RF energy. That's just the energy that exists coming out of your system. The job of an antenna is to shape the dough. Let's look at it this way. If you were to look at a perfectly circle antenna, which I will not be able to draw, from the side and from the top, any antenna's job is just to shape that in some way. Now, in other videos, we're actually going to go through what those different antennas are, what shape equals what kind of an antenna. But the idea is both on the side and on the top, known as elevation, also known as vertical, and also the top, which is azimuth or horizontal. These are the different planes that you look at an antenna. If you can imagine some antennas you may look at from the side, and it may, look like have this kind of a shape to it. And again, we'll go through all this, and then maybe from the side it looks like this, but from the top it looks like that. But the sole purpose of the antenna is to shape energy into a direction or into some other type of shape. Just imagine that ball of dough or that balloon, and you start pushing down. Just like we've done here, if I could take it and start pushing, it kind of makes this, from the side, a donut shape. And that donut shape makes, of course, when we push down, it makes it bigger. That's all an antenna does. That's its job, is to shape the energy. Now, we hear of energy of this shaping as gain. A lot of people will say, and we properly say, what kind of gain does that antenna have? Technically speaking, an antenna does not, of course, create more energy. If so, we would have we'd be solving our energy problems. But again, it's just shaping that energy. But that result is what we call gain. In order to talk about gain, we have to have some sort of measurement for it. The measurement for gain is done in decibels. In fact, if you've watched some of the previous videos, you've heard me say some of the terms. dBd, dBi. These are terms for measurements for antenna gain. We're going to stick with one in particular, that is dBi. Let me get rid of this here. The dBi is the most accepted and the most commonly used in the Wi-Fi industry. There are other industries, of course, amateur radio, cellular, that may use different terminology because there are multiples. But dBi is what we're going to stick with. If you remember way back to the earlier videos, you'll remember that anything with dB is relative. But when you stick a letter after it, it means relative to something. The I stands for Isotropic Radiator. That's a very fancy term for meaning an antenna that is perfectly spherical. A perfect ball, if you will. From the side it's perfect, from the top it's perfect. That antenna does not exist. It is physically, new word for you, impossible to make an antenna that perfectly covers, has a center transmitter, and perfectly covers in a circle in both directions. Can't be done. But it is theoretical, and we are using that theoretical as a point of measurement. So the decibel relative to this theoretical circle is called a dBi. So if we go back and redraw our antenna, let's just, we'll get rid of this one for now. And we have an antenna that shapes it similar to what I had drawn before. The measurement between here and here is dBi. We could just say, okay, that's twice as much. That's a 3 dBi antenna. Now, the measurement of antennas gets very complicated. And fortunately, most of us, we don't really have to deal with that unless we're engineering a new antenna. Because there are different, an antenna is never perfect like this, and there's always lobes, different kind of lobes that come out, and kind of squirts different directions. How do you measure there, or do you measure here? And then there's the fall off. Okay, well, how far out do I measure versus what does this curve look like? That is all fine, and it's good information to have. And if you're interested in that, I recommend you read up on it. But for the simple purpose of how much gain does an antenna give me, it is measured in dBi, which is just the change from the isotropic radiator to the peak gain in the direction you want it to have, the design direction of that antenna. Now, antennas are designed by what's called wavelength. Antennas are different sizes. I think if you were to look at an AM radio tower or FM radio tower versus the satellite on your house or even your cell phone, you'll notice there's a physical distinct difference. If you remember back to wavelength, it's actually the literal length of the wave. Frequency is directly dependent on that. So lower frequencies have bigger wavelength. So smaller frequencies, shorter wavelengths. Most antennas are designed in 1/4 or 1/2 wavelength. As an example, a 5 gigahertz frequency has about a 5 centimeter wavelength. So if we're going to design a 5 gigahertz antenna, it would be 1/4 of that. That's a good example. Way back in the day, in about 2001, my first introduction to Wi-Fi was trying to do a long-distance shot. Actually, at the time, it wasn't all that long. It was about a 1 mile shot, 1.5 kilometer shot. But we didn't have, this was out in the country, we didn't have antennas to go buy or simple access to that. So we built one. And one of the first things I learned about antenna construction was this quarter wavelength concept. So we took the frequency, in fact, at this time it was 2.4 gigahertz, which is 12 centimeters. So we took the 2 gigahertz, the 2.4 gigahertz, and that's, again, a 12 centimeter wavelength, somewhere in there. So we ended up spacing our antenna components 3 centimeters apart. That's 1/4, of course, of 12. So that was my first exposure to wavelength versus antenna design. I mean, you see many different antenna designs out there, but most of them are based on this concept. And we have a lot more to learn about antennas, but hopefully this is a good primer. Antennas, the whole antenna's job is just to shape power. If we want to send signals one direction really far, but no other direction, an antenna can do that. Or if we want to just cover a nice donut shape area just local to us, a different type of antenna would accomplish that. The dBi, signal referenced against this perfect circle called an isotropic radiator, and when an antenna is designed, you can actually, if you actually look at an antenna, you'll get to the point where you look at it and you'll be like, oh, I can tell that's 2.4 gigahertz versus 5 just based on the physical size of that antenna.